Data science involves extracting meaningful insights from structured and unstructured data using methods from statistics, mathematics, programming, and machine learning. Here are the key steps in data science: data collection, data cleaning, data analysis, data visualization, and building predictive models. Why Python for data science? Python is widely used due to its simplicity, extensive libraries, and active community support. Libraries like Numpy and Pandas make data manipulation and analysis efficient and powerful. What is Numpy? Numpy Numerical Python is a Python library for numerical computations. It offers support for multi-dimensional arrays and high-level mathematical functions. Here are the key features of Numpy: efficient storage and manipulation of numerical data. Functions for mathematical operations like linear algebra and statistics. It supports broadcasting, which allows operations on arrays of different shapes. Please make sure that you have Numpy and Panda installed. If not, you can use conda, install Numpy, and conda install Panda in Anaconda prompt to install these libraries. Importing Numpy and Pandas, we need to import Numpy library before we can use it. We can write something like this: import Numpy as NP and import Pandas as PD. We prefer Numpy arrays for numerical calculation than lists because they are faster and more memory efficient. Here is an example to see the performance difference between Numpy array and list. We create a very large collection of data and store them as list and Numpy array and add 10 to each element. Then we calculate the computation time. The example clearly shows that Numpy arrays are quite faster than list. This is because for list we have to loop through each element and add, whereas Numpy arrays support element-wise operations directly. Numpy performs vectorized operations, applying mathematical operations on entire arrays. Here is a simple example to demonstrate the memory efficiency of Numpy array. The next example shows broadcasting and linear algebra, transposing a matrix. While NumPy provides the foundation for numerical computing, Pandas builds upon it to offer powerful tools for working with structured data. Pandas introduces two primary data structures: series and data frames. A series is a one-dimensional labeled array that can hold any data type, while a data frame is a two-dimensional labeled data structure with columns of potentially different data types. Think of a data frame as a spreadsheet within your Python environment. You can load data from various sources such as CSV files, Excel spreadsheets, or databases directly into a Pandas data frame. In the example, we show how to open an employee's data, a CSV file, into DataFrame. Once your data is in a data frame, you can perform a wide range of data manipulation tasks with ease. Pandas provides intuitive functions for filtering, sorting, grouping, aggregating, and merging data. You can easily select specific rows and columns, filter data based on conditions, sort data by one or more columns, and group data based on shared characteristics. These powerful data manipulation capabilities make Pandas an indispensable tool for cleaning, transforming, and preparing data for analysis. In the next lecture, we will discuss about basic statistics such as mean, median, and standard deviation, and use matplotlib library for data visualization. So stay tuned and please subscribe.